Okay, this is Circuit Analysis Lab. We're doing experiment number 4, and we found in experiment number 4 we need a 100 ohm resistor and a 470 ohm resistor. So first thing we'll do is go find them. So we look in the drawer marked 100 ohms, and we find a resistor out of there. And we look at the 470 drawer. We get a resistor out of there. We look at the color code to make sure that we think it's right. And we can't really tell with the background we have, but those might be the correct ones. All right, well. And I want to hook up our circuit so that our power supply goes through the amp meter, through the two resistors, with a voltmeter going across the one of the resistors. So that's what we're going to do. So we're going to come with our red wire. We're going to take our red wire and hook it up to our power supply on the plus. And we're going to take our black wire and hook it up to the negative. No, we're going to use the, we want to use B, right. But B is the one that was going overload, right? Oh, was that one? Okay, so it really doesn't matter which one we use. Okay, and we look at those and we see that we're a little bit too much rubber bound in both of them. We're going to bring them out just a little bit more. Okay, and then we're going to take from the power supply, we're going to go to the amp meter. From the amp meter, we're going to come back, just like we did the last time. And then we're going to go from the positive side through the 470 ohm resistor. So positive to some location through the 470 ohm resistor. Nope, just over here someplace. Yeah, that'd be fine. And then from that same row, and we're going to take it over to the power supply negative. Okay, so that's what we're going to do. And then we're going to take our voltmeter, which is going to be underneath our power supply, and we're going to use it to measure the voltage across the resistor. No, red and black. No, the other red. All right, that's good. And so put these guys across the 470 ohm resistor. And if you hook it up that way, it's going to say the voltage is negative, which we don't want to do, so we want to hook it up the other way. Yeah. We don't really care if it says negative because we're smart enough to mark it as positive. Okay, so now we got our apparatus set up and ready to go. And what are we supposed to do? We're supposed to go and set our voltage supply for 14 volts. So I'll crank up the voltage supply to 14 volts. Yeah, that looks like 15. So crank it down. No, you're not looking at the guy below. That's the one only across the one resistor. That's right. Yeah, so you want to have 14 on that guy. 10, 11, 12, 13. Well, that's probably close enough. And then take the amp meter and change the range so we can see it. And so there we go. So now we got 24.9 milliamps flowing in the circuit, and we see the voltage across R1 is 11.6, and then we're going to move the voltmeter to measure the voltage across the second to 100 ohm resistor, and we see that it's 2.4 and 11.6 and 2.4 makes 14. So we have a total of 14, which is what we're supposed to have. So we record that in table 4.1, and then we break out our calculator and do a bunch of calculations. Okay, now we're going to move on to the next page, and we see that what we're going to do is the same thing again, except we're not going to have the 100 ohm guy in the circuit. So we're removing the 100 ohm guy. And then we're putting a voltmeter across him. But because we only have one resistor, that should read about the same as the voltage from our other guy. And now we're supposed to crank down the current until we have 1 milliamp. So we're going to have to lower the voltage on our voltage supply until we see 1 milliamp. And we're going to have to go a long ways down, so don't go slow. And that looks good. So we're at 1.1, that's good enough. We need to measure the voltage across the resistor. We see that that's 0.52 volts. And now we're going to do it again. We're going to crank up the voltage until we get 2 milliamps. Okay, good enough. And we see our voltage is 0.97. Then we're going to crank up the current to 3 milliamps. Oh, much better. Yeah. And we see we have 1.43 or 4 volts as it shifts back and forth. We're going to put in 4 milliamps. And we see we have 1.91. Then we're going to go to 5 milliamps. And then we're at 5 milliamps, and we see our voltage is 2.32. And the rest of table 4.2 is calculations you can do. So with your calculator, that will not be a problem. You have pictures to draw, you have questions to answer. That concludes this portion of Lab 4.